Here we go. As I said, this is also a part of problem identification schemes. So we have done in the problem identification scope, we have done feature transfer. We have done 9 screens. We have done trace benchmarking, function analysis. We've done cause effect chain analysis. We've done trimming. So today, now we are going to look at flow analysis. And with that flow analysis, we will also look at trimming of the flows. So if you go by what we were talking about how we looked at function modeling of products, how do you think function modeling of flows would be done? What are the key things that function modeling of flows would require, according to you?
Identifying all the subsystem components who are interacting in the flow.
Identifying all the subsystem components that are interacting in the flow. So think of a flow. Think of a flow of your fee deposit. All of you deposit fee. Huh? Think of that flow for now. What happens there? What happens there when you deposit a fee? How will you make a flowchart of fee deposit mechanism?
Like first log in by student, and then after that entering the amount of fee, and after that submitting it via any platform like card or UPI payment or NEFT. And that's it. And after that, receipt generation.
So we
After that, what? Yeah,
so we also choose like which branch or which, like the type of student we are, bachelor's or master's, and automatically at the back end there it's fed like how much fees we have to give. So once we select or once we provide our roll number, they give us the whole breakup and then we pay accordingly.
Okay. So what are these? Are these interactions between components, or what is happening here? Are you really interested in components or the steps? Interaction between steps, handshakes between steps.
Can we say that like the components are being replaced by processes, and the interactions are being replaced by flow between those processes, something like that?
Yes. So look at it also like this. While we as software engineers and as electronics engineers would be thinking of stuff in terms of movement of information, when Altshuler studied these patents and everything, at that point of time, information was not as much a in thing. What was more in thing was something like what you would call as fluid mechanics. And Altshuler therefore initiated or added this technology or this thing of flow analysis inspired from the concept of fluid mechanics. So we will see just now that different boxes that you would have in your flow chart could be considered as different pipes, and the bandwidth or the throughput of these pipes could be considered as the diameter of these boxes, or these steps could be considered as the diameter of these pipes, and so on. Okay. So what function analysis for products we did over here, when we say that we're doing function analysis for processes, we are saying that we now identify functions instead of components. And a process is a sequence of actions or functions on material objects. A technological process is a process that uses material objects, such as, now over here we have added, as time has evolved, we have added stuff like information, data also into it. But when Altshuler did it, information might have still been there, but data definitely was not there. Energy, labor, material, all those things were there, but these are what were added much later as say computing paradigms evolved. Okay. So what we do over here is we want to build a model which includes functional contribution of each operation. Okay, you wanted to log in. What is the importance of this login? And the corresponding cost. That to ensure your login, I have to maintain a server that does this, or this is the load of the server that is consistently and continuously given to the login process. So that kind of stuff. So you corresponding cost, function type, is it critical, is it not critical? We will just look at different function types and performance. Just like for functions and product modeling, product function analysis, we saw the performance. Over here also there is a concept of performance. But yes, we're talking about functions, and a series of functions is what is being called as a process. And we rank the functions also, just like we do in product modeling, and that information is used for trimming. Okay. The outcome of function analysis of processes is a function model, which also lists down functional disadvantages, so that in the subsequent stages of analysis, those disadvantages can be removed. So it is a kind of parallel of product analysis, but you will see handling changes a bit, and therefore you may find applying flow models on your algorithmic problems much faster, much more convenient than the function modeling that we did earlier. Okay, let's take an example. Let's take the example of reheat and blow process. What is reheat and blow process? Can anyone tell? So those of you who drink Coke, Pepsi, all that, you see the bottles there. So those bottles are actually made out of these pellets. And these pellets are plastic pellets, which are put into a mold. Like over here, the plastic pellets, they are put into a system, they are heated, then put into a mold and molded according to the shape of what you want, according to the shape that you so desire. So RBM process involves injection molding, where plastic pellets are plasticized and put into a molding machine, melted, heated, and then pushed forward. Once that happens, once the liquid plastic is available, you create preforms. So even if the 1 liter bottle would be this tall, the preheat forms you will notice are just this small. The preforms are much smaller. You transport the preforms from one place, from where you made the preforms, into another place. You organize them. For example, you put them in a kind of a belt or something like that, so that they are more controlled. And then once that is done, you put those small preforms into an injection mold and blow heated air into it. As more and more air goes, the preform expands gradually and finally takes the shape of the finished bottle. Okay. After the shape is there, then you cool the bottle, and then the bottle, you will notice, may have small rough corners or something here and there. From wherever your mold had a little gap, some plastic would enter in that place also, and there could be some such stuff. So that part is removed. That part is trimmed. That seeps through the mold during manufacturing. That part is trimmed. Now, are you able to understand the process? Any questions about the process? Are you able to visualize it? Okay. So now this is the way bottles are made. But there is a problem. What is the problem? The problem is that if temperature, if the the plastic is heated beyond about 115 degrees C and then quickly cooled, then what happens? There is whitening of the bottle, and the bottle does not look to be good. See, the bottles that you see coming to your homes, they do not have any whitening of plastic happening anywhere. They're all transparent. Why? Because the color of Fanta or Maza or whatever it is that you're drinking, uh, that should stand out, that should come out, and people should be able to purchase the bottle getting excited by that color, if nothing else. So that haze and stress whitening is something which is not desired. And one thing also that we see is that this trimming part that we talked about, this trimming part, this takes time. You have to remove all these extra plastic that has seeped through to give the bottle the shape that it really was intended to take. So this is something which is costly. A costly process doesn't really add much value. So this also needs to be removed. So now we start to do function analysis of the system. So is the problem statement clear? Okay. So now we start to do the function analysis of the system. So what does function analysis entail? Function analysis, again, we start with what is called as component analysis. Over here, components are operations. Operations where we say that a component, you list down what all operations are happening, different functions that are happening, and how, and then you kind of, in the function modeling stage, you connect them. Let us look at the same example, and let us look at how this would be modeled.